Hello everybody, in today's lesson we're going to be doing examples on absolute extrema. Now, just a recap on what absolute extrema does. Absolute extrema is basically finding out the minimum and the maximum of a function or graph. And this is using the concepts of derivatives. Derivatives. Okay. All right. Now let's get this lesson started. Okay. So we can start with the first question. And let me scroll down here first. Okay. So first question, let's say y equals negative x cubed minus 6x squared minus 9x plus 3. So for this function, we had to find a minima and maxima for it. So first of all, you take the derivative of both sides. So the derivative of this equation will be negative 3x squared minus 12x and minus 9. Okay. Now, after you get this out, you can take out x. So you can factor out x. So it's negative 3x parentheses x plus 4 and then minus 9. So, and we know to find the minima and maxima, the function that you're taking the derivative of, so y derivative has to be 0, right? Because at the minimum maxima, the slope for derivative is 0, so that's why. So now 0 equals negative 3x and parentheses x plus 4 equals not equals minus 9. It's supposed to be equivalent to 0, so that would mean x has to be, well, you can't really find out what x can be yet, so we have to simplify this even more. So um, we know that we can't really factor out x, so we can cross that out and try something else. So we factor out negative 3 to get x squared plus 4x plus 3. Now we have something that we can work with, and then this one, x squared plus 4x plus 3, if you use the cross product method where it's 1 1 3 1, we can find that x can be x plus 3 times parentheses x plus 1. That will work perfectly for factoring out this equation. So now with this equation listed, we can know what x equals to make the equation to be equivalent to 0. So right, so 0 equals this equation. So x for this case will be equal to negative 3, and x can also be equal to negative 1. So this is the coordinates where a minima or maxima can happen. So we don't know yet if it's a minima or maxima. All right, so now here is the key part. To find out whether where x equals negative 3 is a minima or x equals negative 1 is minima or maxima, we have to take the double derivative, right? We have to take the double derivative of this function that we have above. So we have to take the double derivative of the first derivative that we have already taken. So negative 3x squared plus 4x plus 3 has to be taken to another derivative. All right, so this will be just let's see, using product rule, we could say negative 3 times the derivative of x squared plus 4x plus 3, so that will be 2x plus 4, just 2x plus 4. So this one we could simplify that to be equal to negative 6x minus 12. All right, okay, now that we have this here, so we know the rule that plugging in x, if it is greater than 0, that means that it's a minima. If it's equal to 0, that means it's a changing point. And if it's less than 0, that means that is a maxima. All right, so now we just plug our x coordinates into this equation, negative 6x minus 12. So our x coordinates is negative 3 and negative 1. So let's just write that down first. X coordinate is negative 3 and negative 1. So now we just plug it in into this equation right here. Okay, so when x equals -3, it will be 18 minus 12, which equals 6. When x equals -1, it will be 6 minus 12, which will be -6. So when x equals -3, that will be a minima. So this will be a minima right here. And then when x equals -1, there will be a maxima. So right now we have found a minima and maxima for the respective points in this graph. So that is your answer to our original question, and I hope you have found this lesson helpful. I'm sorry that this has taken a while to solve, but when you know the processes of solving it, you'll be really quick, efficient, and simple to solve absolute extrema.